Hello, if you're here, it's because there's confusion in this lab for 1.05 measuring physical properties. When you watched the video and you looked at the lab report, you probably noticed that things look different in the lab from the video that you were watching. And I was aware of that issue because the video I made last year, and I knew that there were some changes in how that lab report looked. But when I went into the simulation and looked at things that way earlier in the year, I didn't notice a major change that was made in the simulator. So you may have gotten stuck in the section that talks about density because I never mentioned it in the video, and it's very confusing in the simulator. I want to do a shout out. Thank you to a student who asked this question. She was brave enough to ask that question and say, I'm not really sure I get this. And because she asked that, I was able to immediately look in and realize what the problem was. So always be brave to ask those questions. All right, so we're going to take a look at this density. Basically, in your lab report, if you worked through the scores and data for flexibility, magnetism, thermal conductivity, and electrical conductivity, that matched what you see here in the data table on the lab report. Those numbers, if you recorded them, they are just fine. Where we start to get into an issue is the section where it starts labeling 10 grams for mass across the board. And you're like, what's going on here? And it's not in the video. So I made this video to explain it. When you test for density in the lab, they are testing automatically with a sample size of 10 grams for each of the materials that's being tested. So that's why 10 grams is the same across the board. Now, density is determined, the formula, if you remember back, density is mass divided by volume. So if we know the mass is 10 grams, we're just going to divide by the volume and then be able to record the density. However, they don't just give you the volume. You have to calculate the volume. Let me show you how. If we open this up, we're going to see just what I've told you. And it tells you that the formula for the volume of a cube is its side length cubed. Now, each piece of material is in the shape of a cube. So you will use this formula for all of the materials. And I'll walk you through a couple of them just now. Once you've determined the volume, you will be recording the volume in the lab report right here in the volume row for each material, and then you can come through and determine the density. So let's get started. Let's do the wood piece. So when I move the wood piece onto the block, it tells me that the mass is 10 grams. We already knew that. The density formula is mass divided by volume. We know the mass, we don't know the volume. The volume of a cube, again, is the side length cubed. And the measurement of one side, they took a ruler and they measured the side length. It's 2.5 centimeters. So the side length is 2.5 centimeters. What does it mean to cube that? Here I have an image of a cube, and the formula is length. So if I measured this side, length times width times height is going to give me the volume. Now, a cube is an interesting shape because all of the side lengths are identical. So if the side length of this is 3, the length, the width will also be 3, and the height will also be 3. So the formula becomes x times x times x, one of the sides times the second side times a third side. So let me give you that example before we work with the wood block. If I had a measurement here of 3 centimeters, I would in my calculator do 3 for the first x times 3. I don't hit enter yet, times 3. Then I hit equals and I get 27. So the volume of a cube with a side length of 3 centimeters would be 27 cubic centimeters. All right, but our sample wasn't 3, it was 2.5. So one length is 2.5, so I'm going to do 2.5 times 2.5 times 2.5. And that's shown right here. So 2.5 times 2.5 times 2.5 a third time equals The volume is 15.625. So I'm going to put this into my lab report. I'm not able to put it into the data table because it's asking for density. And I'm not there yet. This is the volume. So the volume comes in here, 15.625. And now I'm going to clear out my calculator and I'm ready to take mass, 10 grams, divided by volume, 15.625, to determine the value for density. So 10 divided by 15.625 equals 0.64. That is my value for density of this material. And that can go into this table. And then save and close. All right, I'm going to clear this out. Let's do one more example together. The clay brick. I'm going to bring the clay brick down. Same information here. Mass is 10 grams. Density equals mass divided by volume, but first we need to determine the volume. The volume of a cube is the side length cubed or multiplied by itself 3 times. Our measurement is 1.7. So I'm going to come here. The side length is 1.7. So 1.7 times 1.7 times 1.7 will give me the volume for this material. 1.7 a second time, cubing a third time, equals 4.913. This is not density, this is volume. So we're going to put that in because I can't put it in here. It's asking for density, and this is my volume. So I'm going to come back into here, put my volume in, 4.913. Whoops. Okay, now I'm ready to calculate the density. Clear this. 10 mass divided by volume equals density. 10 divided by 4.913. 10 divided by 4. The density, I'm going to round this up, 2.04. The 5 here is going to round that up to 4. And then I can put that into the lab report here and save and close. And then continue doing the same thing for the iron block. Get your side length. You're going to multiply the side length by itself 3 times to get the volume. Enter the volume in to determine your density. 10 divided by the volume will give you the density report, which you can then put back into here if you want to. This data table is not, it doesn't get turned in, so you can essentially write anything you want on it. This is the one that's going to matter. So I hope this was helpful to explain to you how to determine the volume and density of the materials that are used. So sorry for the confusion in that original video. And again, a huge thank you to that student, you know who you are, who was brave and brought up this question in the group. All right, if you do still have questions, please don't be afraid to ask them. There's never a silly question, and you end up oftentimes helping out a lot of other people. So email me, ask me for a Zoom meeting, whatever you need to do. Let me know the questions you have. I'm here to help you out. Bye.